multiplied with the 7, which
Yeah.
eventually makes everything 0, right?
Yes.
So what will be the general formula? 2ax to the power 1, we don't write that, plus p, and that would be a differentiated form. Okay.
Yeah.
So now what will this be differentiated? Like, what's the answer? What would be the answer?
8x plus 8x plus 5. 8x
8x
plus
plus
5.
5. Yes, it's 8x plus 5. Okay. And why do we need that? Why do we need the differentiate? Why do you have to differentiate a quadratic equation? Do you know that?
I don't know that.
Just write it down in somewhere that we need to differentiate something because we have to find the gradient of that equation. Okay. To find,
Oh, to find gradient of that equation.
yeah, to find the gradient. Okay. Because let's say if it was a linear equation, which we'd say 4x plus 5, that's a linear equation, right?
Mm-hmm.
And if I were to differentiate this thing, what would be the answer?
The answer would be 4
Just
plus
4.
a
Just 4, no pluses. So um do you know that the gradient of a straight line is a constant?
maybe.
Acha, let's say, what do we understand by gradient?
It's like y2 minus y1. Oh no, x2 minus x1 divided by y2 minus y1.
The first one was right. Y2 minus y1 divided
Oh,
by x2 minus x1. But that's the formula you have said, right? But what do you understand by gradient, like, in generally, in
like
general terms?
slope.
Yeah, basically it's the slope, right? And
Yeah.
let's say this this is a graph of a straight line, and this straight line going down is the slope of this graph, and which gives us the gradient, right?
Yeah.
Why do we let's say, why do we do this thing? Why do we put on a graph and draw this line, like, for what? This is for various reasons, right? Because we have to find the rate of some equation or rate of something that is decreasing. For example, if I give, let's say, temperature here on the y-axis and time here on the x-axis, what will this graph tell us? Can you tell me?
This graph is of directly proportional,
Yeah,
I
like,
guess.
yeah, that's okay if it's proportional. It's not directly proportional, but it's proportional. But like, in which sense? Like, tell me in Urdu or any general term that temperature घट रहा है या फिर कुछ भी क्या हो रहा है?
It's made like temperature is decreasing over time and
The
it's inversely
temperature,
proportional.
yeah, the temperature is decreasing over time. So anything that is over time, we call it rate. So basically, this is the rate of decreasing temperature. How fast the temperature is dropping. That tells us, this graph tells us that. Did you get it?
Yeah.
Sure. Tell me if it's getting real complicated. I will just stop there because I'm trying to develop a concept. Like, how much do you know? I'm just trying to find that. Okay.
No, sir, it's clear as glass.
Okay. Now let's say, uh, if we, how do we find the gradient? We need to. What's this? What are the steps of finding a gradient?
First, we need a graph, and then we would just put the formula and write the values.
Yeah, like, um, where do we find the values? At first, we need 2 points. What? 2 points
2
is
point.
needed. Okay. Why do you
Yeah.
need 2 points or two coordinates? Because without that we cannot proceed. Okay. And then
Yeah.
apply the formula y2 minus y1 divided by x2
X2 minus
minus
X1.
x1, right? That will give us the gradient. And if we find the gradient of a straight line, we will always see that the gradient is a straight line, because let's say no matter where you point, the slope is exactly the same. See, here, here, the slope is exactly same, right?
Yeah.
So the gradient will be a constant value. For example, 2, 3, 4 by 3, 1 by 3, anything but a constant value. It won't change, right?
Yeah.
Did you get it?
Yes, sir.
So let's say the gradient of this graph is 4 or minus 4, because it's a negative gradient. So minus 4, okay?
Yes, sir.
So that's basically where I found it from this equation, that if it's a linear graph or it's a linear line, the gradient will be what? A constant value, and it won't change over the time, or like any point. It won't change, right? Because at any point the gradient is what? The steepness is what? Or the slope is what? Constant, right?
Yes, sir.
Now, what if we bring in a quadratic graph? What will happen then? Let's
Um,
say we bring this graph.
या
Okay,
U और उल्टा U.
या उल्टा u, and इसमें क्या होगा? uh, is the gradient constant? यहाँ पर क्या gradient constant है?
No, sir.
um, like in this point we have to find the let's say what, each of gradient of each points, right, individually. Because let's say I'm here to find this gradient, this point's gradient, and this gradient, this slope will be like this, right?
Yes, sir.
And how about this point? For this point the slope will be more like, no, not like this, more like this, right?
Yes, sir.
Do you know what a tangent is?
Tangent, no, sir.
You don't know tangent is like, okay, fine, that's okay. But are you understanding that the gradient or the slope of this graph is like decreasing over the time?
Yes, sir.
Because at this point the slope is completely horizontal if I draw a straight line, and this straight line through the curve is called a tangent.
Yes,
Okay,
sir.
are you getting here? Like I'm getting too fast, tell me.
No, sir, I'm getting it.
Okay, so um
The line
we
U is
we
touching
cannot
the graph with the tangent.
kya?
The line where the U is touching the graph, it's called the tangent,
Yeah,
right?
yeah, that's that called tangent, yes. And we can deduce from this graph is that tangent is what, changing, right, at every point. Because if I were to draw the previous linear graph, what was the linear graph? The,
That has just a straight line,
that was just a straight line, right? And the slope or the gradient wasn't changing at any point, was it? It was
constant.
the exact straight line, yeah. But as it's the exact same line, we can use this formula y2 minus y1 by x2 minus x1, because at every point the gradient is same. So it wouldn't matter if I just take this type of two y's and two x's. But in this position I cannot really use this formula to find the gradient, because the gradient is not constant. When we can use this formula? When the gradient is constant. But यहाँ पर क्या, gradient
यहाँ
constant
पे
नहीं है, right?
yes, sir.
So we cannot use this formula. So how do you find the gradient? यहाँ पर क्या gradient नहीं है? Gradient है, right?
Yes, sir.
But we cannot use this formula. So what do what we can use now?
We would use the tangent thing.
We can draw a tangent, yeah, and then find 2 points to draw. Let's say what? Draw a y2 minus y1 format, right? Or to calculate it, right?
Yes, sir.
But if we draw a tangent line, let's say we're drawing a tangent line and we want to find the gradient at this point, okay?
Yes, sir.
So I drew a tangent at this point and I have to find the gradient of this line, cause the gradient of this line at this point and the gradient of this curve at this point are the same, because they meet at the same point, see,
Yes,
right?
sir.
So if I can find the gradient of this curve, it doesn't matter which point, it can be this point or this point, because all over the line the gradient is same. So if I find this gradient, I can tell this gradient also, right?
Yes, sir.
So how do we actually find this one if we don't know the coordinates exactly of this line? We can draw lines like that, right?
And we would find the gradient of this tangent, and then we would just
Yeah, like
assume that it's a gradient.
yep. Now that's a hassle for us. Okay, that's why the mathematicians did what? They find the dy by dx. Do you know what this d means?
Differentiation,
No, this d means change in delta. What?
change, delta. So
Yeah,
what is delta?
what?
What is delta?
Delta means change in. Change. A change is
Change
called delta. Okay.
terminology.
It can be anything like something's change or something's difference is delta. It's basically a term. Understand it?
Yes, sir. So
Now,
delta is a triangle.
what?
So I studied in physics that delta was a triangle thing.
So yeah, yeah. It is the symbol. This symbol.
Okay.
Exactly same. Just this is the symbol of delta. Okay.
Yes, sir.
Now, let's say when we were using this formula y2 minus y1 by x2 over x minus x1. Okay. Um, what we are actually doing is we are finding the delta because let's say we know these 2 points. Okay, we know these
Mm-hmm.
2 points. This is y2, this is y1, and this is x1 and x2. Okay,
Mm-hmm.
how do you find the x value? From the bottom line, right here and here. This is the
Here.
x1 and x2, and the y value would be from here, right, which is y1, sorry, y2 and y1, right?
Y. Mm-hmm.
So what was the actual formula? Y2 minus y1, which is basically, see, we are subtracting this whole thing from this thing. Sorry, we are subtracting this whole thing, this y2 from, sorry, this y1 from this y2, this whole thing. So basically, this is giving me the difference or the length of this part, right? If I were to subtract this y2 by this y1, it will give me this part, right?
Yes,
Do you
sir.
get it? Do you get it?
Yeah. Yes,
So
sir.
basically, this is the change in y. Basically, this is the change in y. The y was this, and this is the change of them, and
Change in Y.
we call it dy, the change in y. Do you understand it now?
Yes, sir.
And exact same thing. This will be what? The change in x, which is dx, right?
These.
That's that's where the dy by dx came from. Dy by dx thing. This is basically change in y by change in x, which is the another form of this thing. Clear?
Yes, sir. It is clear as glass.
Okay. If it's clear, then let's get to the differentiation thing. Now, basically, drawing a tangent and doing all this stuff is kind of a hassle. So the mathematician invented what? Differentiation. Okay.
Yes.
If they differentiate it, this will give us a form which is basically let's say আমি sorry let's say मैं यहाँ पर क्या कहते हैं I wanna find the gradient on each and every point. Wouldn't be that a really big hassle, or like I know 3 points and I have to find the gradient on those points. Okay, let's say I know the value of um, x equals to 2, x1's value is 5, and x2's value is 7. Okay, is there any problem?
Mm. No, sir.
Okay, now I have to find these three x's gradients, or like the gradients at x equals to 2, x equals to 5, and x equals to 7. Okay, now I
Mm.
have to draw tangents every time on these points is, and then see, the 7 is not even in the graph, is it?
No, sir. It's not.
It's somewhere in between here, right? So I don't even know this point, so I cannot really find it, can I?
No, sir.
So that's why when we differentiate a quadratic form and we find this format, okay, we find this equation, right?
Mm-hmm.
And we can actually do what? We can actually plug those values of x's, which was 2, and then what, 5, and then 7, right? If I plug those values of x in here, I will find the gradient at those points. Okay,
Yes.
so 8, 2 plus 5, this will give me what? Say 8, 5 plus 5. What are the values of dy by dx?
So 40 plus 5, 45.
um uh, the first one,
Of the
16 plus
second
5,
one.
right? 16 plus 5, first one is 21, and then 45, and then the last one would be 8 sevens are 56 plus 5, which is 61, right? So see,
Yes, sir.
it was so easy to find the gradient at x equals to 2, x equals to 5, and x equals to 7, rather than drawing the each tangents at every point. So wasn't it
Yes,
easier?
sir. Yes, sir. It was quite easier.
Yeah, so basically that is why it was invented, to find the gradient at um like simpler form. And why do we need the gradient? I told you earlier, to find something's
Um,
rate or
to
something
find
like that. Okay.
something.
Okay,
Yes,
like
sir.
how fast the thing is growing or decreasing. Let's say if I were to see in this graph, and it's a temperature against time graph again, and I would say that the initially the temperature was decreasing drastically, right? And then at a certain point the temperature stopped decreasing and then increase started increasing, right? That's the prediction I can say, or that's the observation I can tell, viewing the graph, right? Uh,
Yes, sir.
समझे?
Ji,
Clear?
sir.
Okay, so that was the differentiation part and why we use it. And I guess you're pretty much understanding the differentiation now, like how to do it and why we do it, right?
Yes, sir.
Now let's
Sir, it
say,
is clear as
yes,
glass.
what?
It is clear as glass.
Okay, okay, no worries. Alhamdulillah, my pleasure. Okay, and then uh, we will say I'm giving a polynomial graph, okay, a polynomial equation. Let's say 16x cube plus 3 by x square plus 7x, let's not say 7x, minus 7x plus 10. Can you find me the gradient of this, the equation of the gradient of this graph or this equation?
Yes, sir. We would multiply 11 by 3, which is
uh,
33.
11 by
X,
3, that's 16.
oh, 16. Oh, sorry. 16 by 3, that is um
That was
16,
48.
48, and x to the power of 2,
Okay, and then
and then 3 divided by x to the power of 2. Sir, what would we do in this part?
okay. So, do you have the idea of indices and arithmetic algebras, like the
Yeah,
format we can multiply and divide stuff? Like, let's say, there's something 2 over x, okay, and what's the power of x? That is 1, right?
1.
I can write it in the form of 2 to the power x minus 1. Did you know that?
Oh, yes, sir.
We have to do that here. So basically, I can rewrite this in the form like 3x minus 2. And now it's easier, right?
Yes, 6 minus, 6x minus 1. X की power minus
6x
1.
x to power minus 1. Mm-hmm. Arisha, that's wrong. Let's say I have to multiply minus 2 with this 3. So it wouldn't be 6. It would be minus 6 at first. Okay. It would be minus 6. And then what's the power of x? Already minus 2, and I have to subtract all. minus 1. So minus 1 is minus 3, right?
Zero, yeah.
So x would be to the power minus 3.
Minus
Did,
3.
did you get it? Samjay?
Yes, sir. Yes, sir.
Okay. And then what would be the next value?
Minus 7.
Would be minus 7. And we won't write this one because 0 multiplied by 10 would be 0.
0.
Okay. And it doesn't matter if it's a known graph or an unknown graph, you can do it anyway. Let's say I give you another one. 5x to the power 7 plus 4x to the power 5 plus x cube plus 7x square minus 14x. Let's say I told you to differentiate this one. Would it be matter like if it's a known or an unknown graph? It wouldn't matter, right?
Yes, sir. Because we know the format.
Yeah, we know the format, we just have to apply to it. So what do? We just multiply 5 into 7, which is 35
45x to the power of 6.
x to the power of 6 plus
20x to the power of 4.
to the power of 4 plus
Plus 3x power 2.
3x power 2 plus
14x
14x
minus 14.
minus 14, and that would give us the
Answer.
answer. And basically, what do we call this format or this equation? This is the equation of the gradient, right?
Yeah.
This is the equation of the gradient, and if we know the value of x, we can find the gradient at point x by plugging the value of x in these positions. Okay.
Yes, sir.
And if it's in this format, we have to at first convert it into this form and then do the math. Okay.
Yes, sir.
Okay. Now let's move on to the integration part. These are the most like problematic topics of pure maths, if you tell me, because most of the students I see like struggle in here, like differentiation and integration. And I have already told you the uses of differentiation. What was the uses? Why do we use differentiation?
Find a value. To find a value.
To find
To find the gradient.
the gradient and
Because to find the gradient and the value.
the value of gradient at a particular point,
Yeah.
right? And why do you use it? We use it to find rate and stuff, so that wouldn't matter right now because we will get to it later otherwise. And then why do we integrate? Let's say, why do we integrate? What is integration? Do you know what integration is?
No, sir.
Integration is basically, let's say, there's an equation of x to the power cube minus 2x square plus 10x plus 7. Okay. And if I were to differentiate it, what would be the answer of it? Tell me.
3x to the power of 2
3x to the power of 2
minus 4x
minus
plus
4x plus
10.
10.
And we would not be writing 7.
Yeah. This was dy by dx. Okay.
Yes, sir.
And basically, what integration is this thing. I will be given this equation and I have to find this equation. That is basically the integration, and the sign of integration is f.
Oh, okay.
F of dx. That's basically the ulta of differentiation, right?
Yes, sir.
Did you get it?
Yes, sir.
And let's say, what was the format of differentiation? If I were to tell you, can you tell me?
We would just be multiplying a number with the power of x, and then we would just subtract 1 with the power.
Yeah, power one with the power. Yeah, okay, fine. And then, okay, let's say I'm writing a generic formula. Let's say b x m plus c, or let's say bx. Okay, this is a generic quadratic formula, equation, right? And I have to write what, let's say, a into n, or n into a, x to the power n minus 1, and then plus b into, sorry, plus 1 into b, x to the power 1 minus, let's say what, or 1 minus 0, right?
Yeah.
And plus c minus 0 is 0. So basically this is the thing. I had to at first
Yes, sir.
multiply the power with the coefficient of x, right?
Yes,
And
sir.
then we subtract, let's say we subtract the power of x by power
The
of
power
x by what?
by differentiation by
No,
one
no,
by one.
by one. Like at first we multiply the power with the coefficient of x. Let's say this is the power and this is the coefficient of x. We multiplied it here, and then what we did, we subtract the n by 1, right? We
Yes,
subtract
sir.
the power by 1. Okay, and then we found the differentiated formula. And about, let's say, the integrated formula would be, mm, a x n plus b x plus c. The integrated formula would be, um, at first we have to add, we will do this ulta, full ulta, okay? And like, um, हमने कहाँ से शुरू किया था, यहाँ से यहाँ पर, यहाँ तक, right? We started from
Yes,
here to here, and now we, for integration, we will start from here to there, okay? But in a reverse manner. So we subtracted the power, right, at the second, here.
yes,
Hello?
sir.
So we have to add the power in here, okay?
Okay, and then we would divide the power.
Yeah, then we will divide the power, right? So let's say we will we add power of x by 1, and then we we
Divide.
divide the power with the coefficient. Okay, so basically,
Yes,
can you tell me what will happen? Let's say, at first we add the power. The power was n, and I have to add it. So x n plus 1. We added the power, okay, and then we have to
mm,
divide it with the coefficient a by n plus 1. Okay,
yes,
and then plus, we again add the power, which is x square, right? This was 1, so 1 plus 1, let's say 1 plus 1, and then b by 1 plus 1 plus c. And this will give us what? This will give us basically this format. So I what I can do to simplify is, and there is there is an, let's say, when we differentiated the previous ones, there was 7, right? And its power was 1, so we had to eliminate the x, because of x was x to the power 0, right?
yes, sir.
And now let's say the value of c is 8. That is a constant, right? 8.
Mm-hmm.
And is there any x here?
No,
Exact same thing. Nope, there is an x. I told you, right? X to the power 0.
power of zero. Yes,
So I had to add this one too, right?
Yes, sir.
So x to the power 0 plus 1 would give me x to the power 1.
Yes, sir.
So it will become 8x. And
Eight.
uh, and and there would be a constant added to it, because for differentiation we eliminated the constant, right? We just eliminated this 7 here, right?
Yes, sir.
So we have to add that constant in here. We don't know the value, but we know there would be a number. Did you get it now
Yes, sir.
fully? Now let's just do it easily. um, Let me just copy this equation. Can you find me the integrated form of this?
Maybe we would divide 48 by 2 and then plus x to the power of 2 with 1.
48 by 2.
It's 24.
Mm-hmm. Arisha, think a bit. Like, what was the rule? At first, for differentiation, we multiplied and then subtracted, and for integration, it will be ulta. X,
Yes,
we have
sir.
to add it first and then divide. See, here.
Okay.
At first, we multiplied the whole thing and then subtracted, right?
Yes, sir. So we would
And
just plus and then we would multiply.
divide.
Divide, yeah.
It was multiplication. Differentiation was multiplication. Integration would be division. Okay. So
Yes, sir.
tell me, what will be the answer? Let's say,
Yes, sir.
okay, I do this one for you. Let's say I have to at first what adds the power. So what would be the addition of the power? 2 plus 1 would be
3.
2 plus 1, right? And then I have to divide the power with the coefficient. So 48, 2 plus 1 would be 3, right?
Yes,
And
sir. Got it.
this will be 3. Then minus 6x. I have to add power first. So minus 3 plus 1 would give me minus 2, and divide the coefficient by minus 2. Okay.
Yes.
And then minus 7x, that would be x, because there is an x to the power 0, and 0 plus 1 would give me 1, right?
Mm-hmm.
And then constant, a variable, a number, that I denote with c, that we denote with c. Clear? So 48 by 3 would give me, what's the simplest form of 48 by 3? That would be 16 x cube minus, let's say it is already minus and I divided it with the minus value. So it will give me a plus value, right?
Mm.
So this will be
Plus
3, 4, 6 divided by 2 is 3. Are you not understanding?
sir, I am understanding it. It's just quite tricky.
Yeah, it's like it's the first time, right? So it will be a tricky, and it will be okay after that. And then minus 7x plus c. Do you get it? I don't know the value of c, but I know there's a c, right?
Yes, sir.
And now if I copy this full and I bring back, I go there. I copied it, this thing. I copied it from here, right?
Yes,
And
sir.
it was the differentiation of this thing, right?
Yes, sir.
And I integrated it and I found this one. Wait. আসে না কেন? আরে,
Yes, sir.
wait, আসছে। Wait, isn't it copying? Huh. See, it's the exact same format here.
Yes, sir. Same to same.
Same to same. And we didn't know the value of the constant, so we kept it C. But here there the constant one given, so this c would be 10, right?
Yes, sir. Minus 10, I guess. Plus 10.
Plus 10, plus 10, it's plus. Now do you understand the concept of basically differentiation and integration? Why do we do integration? We to find the area and volume of some equations, because let's say there is a equation, the graph of this thing, okay, and if I were to rotate it 360 degree, it would form a cone, right?
Yes, sir.
Do you get it? Like if
Yes.
this line, I rotate it 360 degree, it will form a cone, right?
Yes, sir.
And we integrate to find the volume of this cone.
Okay, sir.
Get it?
Yes, sir.
Okay.
Like, in order to find the area of the cone or any object, we use this integration method.
Yeah, yeah, area or volume. Okay, mostly
Okay,
it's the
sir.
volume. And let's say if I were to integrate this for this graph, it would give me a 360. If I rotate it 360 degree, it would give me a shape, right? A weird shape, but it will
Yes.
give me a shape. And that shape's volume would be found out by the integration of this formula. Okay, of its formula. Clear?
Yes, sir.
Okay, let's do some integration and differentiation parts. Hmm, let's see if you understand the whole thing. Okay, let's say 5x to the power 4 plus 3x square plus 7x to the power 9 plus 10x plus 2. At first, differentiate it and then integrate it. Can I
First,
do it?
I'll integrate it or differentiate it.
Do which one you like. It doesn't matter.
Mm, in order to integrate it, we would first add the power and then we would divide it.
Yeah,
So,
you do it on your copy and then tell me.
okay, sir.
Okay.
Sir, what is the power of 7x? It is 1 or 9?
7x to the power 9.
Okay.
Could you do it?
Yes, sir. I'm on last step of
Okay.
integration.
Okay.
Sir, done.
Done. What's the answer?
Answer of differentiation is 20x cube plus 6x plus
Differentiation of
70.
integration.
Uh, First I did the differentiation and then I
Okay.
did the
Okay.
integration.
20x
Plus
cube plus
uh, 6x
6x
plus 70 x 8.
70.
Yeah.
7 into 9 is 63.
Oh, x 8 plus 10.
Plus 10. Okay. And what about the integration?
Um, 25 by 5 x to the power of 5.
25 by 5. Where is 25?
Like, I added 4 plus 1,
Which
that
is
is
5.
5.
See,
Multiply it by 5.
why do we multiply in the integration, Arisha? We
Oh,
don't
you want
multiply in integration, we only divide.
yes, sir. You are right. We
Wait,
only divide.
so this will be 5 by 5, x to the power 5, okay, plus b by 3, x to the power 3, plus 7 by 10, x to the power 10, plus 10 by 2, x to the power square, plus 2x plus c. And this will give us x to the power 5 plus x to the power 3 plus 7 by 10 x to the power 10 plus 5 x to the square plus 2x plus c. Did you get it? No.
Yes, sir.
Is there any problem?
No, sir. It is clear as glass.
Yeah, like now you have to just practice it more, like at least 20 or 50 equations and formulas.